Take a deep breath. Did you know that with every breath we take, we inhale approximately 56 quintillion atoms? That's right, that impressive number has 22 zeros. And it doesn't stop there. Our body is made up of around 7 octillion atoms. Imagine a 7 followed by 27 zeros. Now think of the Earth, our planet, made up of no less than 100 quintillion atoms. That's a 1 with 50 zeros. But let's expand our imagination even further. The observable universe, when divided by the smallest possible unit of volume, the so-called Planck space, leads us to an astronomical number of 1 followed by 185 zeros. And yet, believe me, that's not the biggest number we can conceive of. Let's talk about something even bigger, introduced by physicist Antonio Padilla from the University of Nottingham. He mentioned something fascinating called tree theory. The aim is to create the largest numerical tree possible. Imagine starting with a tree that has just 1 seed. The second tree can have up to 2 seeds, the third up to 3 seeds, and so on. As each level grows, the number of seeds each new tree can have also grows, although it never has to reach the maximum number allowed for that level. This is an intriguing mathematical game where the trees grow in surprisingly varied ways. By introducing a third color to the seeds, for example, tree 3 flourishes for an extraordinarily long time, far beyond initial expectations. Mathematicians claim that this game has an end, but they haven't yet managed to predict when or how it ends. So what does this make us think about the concept of infinity? Infinity has no end. It simply goes on and on. In a potentially infinite universe, every number, every object, everything, no matter how big, will always have a successor. And what does this mean for us, living in a universe that never stops expanding? In the 19th century, the German mathematician Georg Cantor introduced the idea that there are different types of infinity. He showed that although countable numbers include even and odd numbers, both groups are infinite. Astronomers today deal with concepts of infinite densities in black holes and the potentially infinite expansion of the universe. In the 16th century, the Italian philosopher Giordano Bruno proposed a revolutionary idea. Space is infinite and full of countless stars and planets. Moving forward a little, we find the English philosopher Thomas Hobbes in the following century with a more cautious approach. He thought that speculating about infinity was a futile exercise. Today, armed with powerful telescopes and modern science, we continue this quest. We observe galaxies that existed 1 billion, 5 billion, or even 10 billion years ago. The edge of our observable universe is marked not only by space, but also by time. Light, traveling at around 186,000 miles per second, can only go that far in 13.8 billion years. But due to the expansion of the universe, these first galaxies are now around 46 billion light-years away. And the most intriguing thing is that, as we probe the limits of our observable universe, we find no sign of an edge. There's no big sign saying, "End of the universe, please come back." Instead, the cosmos appears to be evenly distributed, without a center or edges, like a perfectly cooked pizza, but on a cosmic scale. The theory of cosmological inflation suggests that, shortly after the Big Bang, the universe expanded rapidly, smoothing out any initial irregularities. So what is the truth? Is the universe infinite or just absurdly large, just like the surface of the Earth, which is finite but has no apparent edges due to its curvature? Cosmologists suggest that our three-dimensional universe could be similarly curved. It's a rather crazy but fascinating idea. A universe without edges, where if you traveled in a long enough straight line, you could theoretically return to the same starting point. To understand this, think about how parallel lines work. On a flat surface, like a sheet of paper, they never meet, but on a curved surface like a globe, they can meet or diverge depending on the curvature. In the 1930s, astronomer Edwin Hubble began to apply this logic to the universe. trying to count how many galaxies he saw along different lines of sight and how these numbers changed with distance. Since the 1990s, armed with more advanced telescopes and so-called standard candles and standard rulers, astronomers have measured the total mass of the cosmos, looking for signs that tell us whether the universe will continue to expand forever or eventually begin to contract. When cosmologists make these complex measurements, they consistently discover a universe that, at first glance, seems to extend infinitely. But remember, just like the ocean that appears flat to the naked eye, our perspective of the universe is also limited by the precision of our instruments. So far, what we see suggests that for the universe to appear flat but still be curved, it needs to be at least 37 trillion light-years in diameter. That's thousands of times bigger than anything we can observe directly. And yes, it could be even bigger. Maybe even infinite? Could it be that out there, somewhere among the stars, there is something or someone watching us? Well, that's a question that still intrigues scientists and the curious. As part of the growing search for extraterrestrial intelligence, scientists are trying to figure out what a message from the stars might look like. And once, something happened that changed everything. The WOW signal. Detected by Jerry Amon in 1977, this signal was loud, unique, and completely different from anything we had ever seen. It hasn't been repeated, and to this day, we don't know exactly what it was. Could it be an intergalactic hello? Who knows? But let's go further and think about the universe itself. It could be that the universe is finite in space and time, or perhaps infinite in both. What if it's infinite in space but finite in time? What if the universe is finite but lasts forever? Finally, we come to an even more baffling concept: a universe infinite in size and duration. How do we deal with a place where any probability, no matter how small, becomes a certainty given eternity? And if time is enough, all things will occur again, repeating themselves in an eternal cycle. This turns the whole of cosmology into something of a paradox, because how can we make predictions in a scenario where everything is possible and infinitely probable? Benoit Mandelbrot was a Polish mathematician who saw beauty and order in the chaos of the natural and human world. In 1958, he moved to New York and began working at the IBM Research Center, a place not to improve computers, but to revolutionize mathematics with them. It was there that he began to explore fractals using computer graphics. And what are fractals? They are incredibly complex structures that you can zoom in on infinitely, and they never simplify. There's always more detail, no matter how close you look. Imagine being able to zoom in on a fern leaf or a Romanesco broccoli, yes, that vegetable that looks like a tree from another world, and never stop finding new patterns. Mandelbrot discovered that this geometry can even be seen in the grouping of distant galaxies. This begs the question, could the entire universe be a fractal? Although this is not the case on large scales where uniformity reigns, who knows what else we might discover? Returning to the infinity of the universe, we are constantly expanding our understanding, just as the universe is expanding. Everything is moving away from everything, like a loaf of bread growing in the oven. If we started from an infinitely dense point, our observable universe was only a fraction of that initial point. And as it expands, everything within it becomes less dense. And here's the most intriguing point. Even with all these fascinating theories, the truth is that proving anything about infinite universes is incredibly difficult, perhaps even impossible. The nature of infinity is so complex that it may not be possible to have concrete evidence that we live in a limitless cosmos. What scientists do then is keep looking, trying to better understand the universe we can observe. If you enjoyed this journey into the unknown, don't forget to like it, subscribe, and comment on what you think might exist beyond our known universe. See you in the next video. Bye.